Hi, this is Jake White, and this is my Physics 2212 Lab 1. So in this lab, we will be investigating charged tape. So in this lab, we're going to create charged tape and analyze physical interactions to calculate their charges, among other important scientific values, by creating a computational model. In order to walk you through this process, I will be reviewing the underlying physics, the procedure, the computational model, and the results. So in the results, I was able to calculate the charges of two pieces of tape using Coulomb's law and the gravitational force. And you can see the value for Q right there, and I'll be showing you exactly how I did that. So first we'll go over the fundamental physics. So first and most important is Coulomb's law, which is the equation or the law that allows us to calculate electrical force. And then we have the nature of opposite charges. So we know that like charges repel and opposite charges attract. And then we have Newton's second law, force equals mass times acceleration. This allows us to calculate gravitational force, which we use in this lab to calculate values associated with the charges of the tape. And then the graphic below, you can see Coulomb's law and the nature of opposite charges. So the materials that we used in this experiment used a roll of clear tape, a ruler, a flat surface, and two textbooks. For the procedure, I created two charged pieces of tape by sticking them to a base tape and pulling them apart. I rubbed a pin in my hair, creating a negatively charged pin, and then held it near the charged tape. The pin and the tape were attracted to each other, meaning that the charged pieces of tape were positively charged. I suspended one charged tape using two textbooks as support, and then held another charged tape below, and recorded the change in position of the suspended charged tape. I then used Glowscript to create a computational model of what I just described, which I then used to calculate the charges of the tape and other values as well. So here's the measurements that I found in my experiment. The length of the tape was 0.18 meters, the width of the tape was 0.225 meters, and the distance between the two tapes was 0.25 meters. So in this experiment and in doing the calculations, we have to make two assumptions. Both tapes have the same net charge. So we can assume this because the two tapes were made in the same process, and that both tapes will be treated as point charges. This is done to make the calculations easier and still a useful model. And also we will assume that there's no air resistance. So here's my Glowscript code. So at the top you can see constants such as Coulomb's constant, the charge of an electron, and then my measured values such as the length of the tape, the width of the tape, and the mass per square meter of the tape, and the distance between the two tapes. And then next you can see where I initialized the values and calculated other values using equations. So first I calculated the tape mass, and then I used that to find the force of gravity. And then we know that the electrical force is equal in magnitude to the gravitational force for this problem. And then I found the positions of both tapes. And then I found R by finding the difference in these positions along with R magnitude. And then finally, using all of that, you can calculate Q, the charge of the tapes. Next we go into the number of electrons, which we found just by taking the charge and dividing it by the charge of an electron, and then finding the number of atoms by taking the area of the tape and dividing it by the area of the atom. And then we can finally get the ratio of atoms to electrons. And then we have the print statements, and then finally we have the arrows and such to create a visual representation of the model, which you can see right here. So the green arrow represents the electrical force, and the yellow arrow represents the gravitational force. And then we have all those calculated values at the bottom. So conclusions. The model matches up with the calculations derived from handwork, meaning that the model is scientifically accurate. The high atom to electron ratio suggests that the tape was highly positively charged. And if one of the tapes were to switch signs, this wouldn't really change much in the model. In fact, nothing would really change except the sign of the electric force. This would mean the tapes would be attracted to each other. And it was extremely important in this experiment to handle the tapes as carefully as possible. This is because excess electrons from tape would transfer to your hand because your hand is neutrally charged. And that's it.